I'm filming this video at night at school so that I can see the experiment very clear in the darker room. And we're going to proceed to the part B of your assessment, which is called the refraction, bending light. Follow me. Okay, so the part B is refraction, and the refraction is the light being bent by the refractive object like this, which is glass block. The glass block is transparent, so it refracts the light. Now, we've set up the light box, we're connected to the power supply, we've placed this single slide inside the light box, we created a ray, we placed it against the block, and we're going to see refraction. I'm going to turn the light off to see it clear, because do it at night. Okay, so you can see the light being bent. You can see how it's bent, so it goes in one direction and it comes out in another. Right? It comes in one direction and it goes in another. And if I place this box like that, we can see that if I remove it, the light goes in one ray, straight, and if I place the block like that, the ray is bent. So this is the bending, this is the refraction. These two lines, you can ignore them, there's a little bit of reflection happening. So I'm going to turn the light on and I'm going to be tracing this block with a red color pencil. Again, look. Clearly we can see something's happening, and this something is refraction. Okay, so sorry, camera problems. So I have outlined glass block, and I can check it, it has been outlined. Now, I'm going to also mark the incident ray and the light that comes into the box with as accurately as I can. With my pencil. Please note that this light is quite wide. It's about 1 millimeter wide. I can use my ruler to clarify it. Yep, it's about 1 millimeter, so it's quite thick here. It's about 1 millimeter, and it varies in thickness. So now we are going to use the protractor to draw the normal line. So we were going to find the normal line. The normal line is the line that is drawn at 90 degrees to the refractive angle, and where the light meets that refractive object. It's the same way here, is where the light strikes the refractive object, and where here at this point, and this is where we draw this normal line at 90 degrees of perpendicular. Okay, so we've marked 2 points at which the light strikes the box, and where we're going to draw this normal line, which is at 90 degrees to the surface. We're going to take the block art, and we're going to draw the line at 90 degrees at this point, at the 90 degrees at this point. Okay, so we're going to use the protractor to do it. We're going to place the protractor lower scale like that. We're going to turn off the equipment. We don't really need it. We're going to place the protractor on the lower scale and mark the 90 degrees there. We can draw, this is a normal line, number 1. We draw it through all the way. And we're going to draw a normal line at 90 degrees, the line at 90 degrees at this point. And again, we can use the scale, place it this way, and mark the dot there, and we're going to draw the line through the 2 points like that. So these 2 normals. I'm going to strike the light again through this glass box, and I'm going to turn off the light in the room so we can actually see the light being bent. So now you can see it a little bit clearer. Okay. Go have a closer look. So the light is bent inside this glass block. You can see it's a little bit reflected from this point, which we ignore for the purpose of our experiment. We just concentrate on this line, right? And if we take the glass away, the line becomes straight. If we put the glass, the ray line is bent. So, how do we know how the light is bent? It's like this. We can see it. It's between these 2 points. The point at which we drew the normal lines. What we're going to do? We're going to join these 2 points inside the glass. We're going to take the glass block away, and we're going to use the orange line to join. Remember these 2 points. Double check. It's in between these 2 points, right? So we join these 2 points. Is bent inside the glass block, and we can put the glass block back. Voila! This is actually true. We did it really well. I'd like to mark the errors like that and like that. So the error of the light coming out of the glass to the air, be air, this is glass, and the light coming in from the air, this is air, to the glass, we pointed the error. Now, what do? We can proceed to measure our angles, and our angles are here in this table. I'm going to turn the light on because I can't see properly when I measure the angles. We can now measure the angles. We're going to first of all measure the angle of incidence for the light entering glass from air. Angle of incidence from the light entering glass from the air. Right. So the light comes from the air to the glass, and we have to find the angle of incidence. This is the band light. We're going to put a small letter B, like this. We know it's inside the glass. And this is our normal lines that we drew. I'm going to put letter N and letter N. Also, this is our incident ray from the air. So where would be the angle of incidence coming from the air to the glass? It's going to be in between the normal and the light ray. So this would be this angle. I call it I for incidence, and I'm going to measure it. And I'm going to place my protractor on the center of the lower scale of my protractor on that point. Find the ray, and this is the ray, and we're going to measure the angle of the incidence, the angle between the ray and the normal. So the angle would be around between 55 and 50. I would say it would be 53, approximately 53, approximately. This really interesting sign means approximately, means not exact. Why? Because I've marked the light is a quite thick line, so this 1 millimeter thickness of the line contributes to this, inaccuracy. So I'm going to transcribe 53. I'm going to write it for the angle of incidence for the light entering glass from the air. Light entering glass from the air, and this is our angle, 53 degrees. This is approximately 53. I'm going to work towards measuring angle of refraction for the light entering glass from air. Okay, so light entering glass from the air, this side, and we are looking for the angle of reflection for the light entering glass from the air, and the angle of reflection would be happening inside of the glass. So we're taking this glass block away, And we're going to find it on diagram. We can find it on diagram by observing the bent line here. We remember that this is bent line and the normal line. So the angle of refraction would be between normal line and bent line inside the glass. So this is going to be angle of reflection. And I'm going to make it pink color. And I'm going to add this little line for angle, and I'm going to make this one green color. This is the angle of incidence with this little sign that means the angle, and this little sign means angle of reflection. So the green one is the angle of incidence and the pink one is angle of refraction. So we're going to measure the angle of refraction, pink color, little sign for angle R, inside of the glass in between the bend line and the normal line, using the protractor, place in the center of the lower scale at the angle, finding the ray, the bend ray, and measuring. So it's approximately, it's in between 45 and 44. I'm going to say approximately 44 degrees. Again, I like to write it on a piece of paper so I don't forget. I look and straight away write it here, so I don't look for my tables. And again, I'm writing this little wave, meaning approximately 44 degrees. Now we're moving to, we have to write it down in our table. So approximately 44 for the angle of refraction, right? We double check it. Angle of refraction, approximately 44 for the air, for the light coming from the air to the glass. And we write it down. Light entering glass from the air, right? Angle of refraction is approximately 44 degrees. Great. So what's left on our diagram is to measure this part. Light entering air from the glass. Light entering air from the glass. So this is the light we're now thinking about. And we're going to measure angle of incidence. So this part. Angle of incidence. Where is the angle of incidence? Here. Right. Angle of incidence would be measured between the line of coming from the glass to the air and the normal line. So where would be that angle? So the normal line is here and the bent ray is here. So this ray is coming out. The normal line is here. So the angle of incidence would be here. And I would mark it as a little sign for the angle. And I'm going to make it a red color. So this is the red color eye angle, as opposed to the green color. The green color is this angle. The red color would be here. Okay? So the red color angle or angle of incidence is in between these ray and the normal line. So we're going to measure it. Again, you know how to do it. We're placing the middle of the lower scale on the normal line. We're finding this ray and we're measuring it's approximately 45. I write it straight away, so we are writing it here, 45. Approximately. Again, because the line is quite thick, so we're not going to have that great accuracy. And we're going to write it down straight away here, so we don't forget. And this is approximately 45 degrees. Okay, 45 degrees for the light entering air from the glass. The angle of incidence of this light. Okay, so this is the angle of incidence of the light coming from the glass to the air, between normal line and this line. Now, the lucky last one is angle of refraction. Great. And it's for the light entering air from the glass. So again, this is this part. The angle of refraction is here, somewhere here. So where it is? It is in between the normal line, which is blue, and the light entering to the air. So I'm going to use blue color to mark it. And I'm going to put little sign as we learned for angle for refraction. Now we're going to measure this angle, again placing the middle lower scale of the protractor on the normal line, and going to see where this ray line is. It's about in between 55 and 50, and again, because the ray is quite thick, we can't really tell exactly. I would say 1 degree accuracy is okay, so between 55 and 53, 54, approximately 54. So approximately this wave sign 54, we're going to transcribe it or write it down into the table here. So this is for the light entering air from the glass. Double check. From the glass, air enters to the air. And this is angle of refraction. That's correct. Approximately 54. Great. I think we've done a good job. I think